My name is Rishabh, and I'm going to talk about the topic AI for Human Behavior Modeling of a subject AI Foundation. I'm from CSE AIML branch second semester. What is human behavior modeling? Human behavior modeling is a process of using a computational techniques to represent, stimulate, and predict how humans think, feel, decide, and act in various situations. It's not physiology. It's a bridge between a social science and a computer science. AI enhanced this by processing massive amount of behavioral data that no human researchers could manually analyze. Think about how Netflix know you will watch a specific show before you even search for it. That is a behavior modeling in action. It draws it from a cognitive physiology, sociology, neuroscience, and now from machine learning. The goal can be prediction. What will be a user do next? Explanation. Why did they do it? Or generational. Stimulate what a human would do in a new situation. Why does this matter? Human behavior modeling has real consequences across nearly every major domain of modern life. In healthcare, it predicts patient non-compliance with medication. In finance, it detects fraud transaction by spotting anomalies in a spending behavior. In education, it identifies when students are disengaged before they drop out. In national securities, it helps anticipate crowd behavior in crisis situations. The scale AI operates at is what changes everything. Older systems could model a few hundred people in controlled study, but modern AI systems model millions of users in real time. That's a paradigm shift. It also raises ethical questions. Who owns your behavior data and who benefits from this prediction? Historical roots before AI. Before AI entered the picture, behavior modeling was done through surveys, interviews, and controlled experiments, all slow, expensive, and limited in scale. Physiologists like Skinner and later cognitive scientists tried to formalize human mental process with a rule-based models. In 1980 and 1990s, expert system attempted to encode human decision-making logic manual. The problem, human behavior is messy, conceptual, and contradictory. Rule-based systems broke down quickly in real-world scenarios. This created a vacuum that machine learning eventually filled instead of handcrafting rules. We let algorithm discover patterns from data automatically. Types of human behavior AI models. There are several categories worth knowing. Predictive model forecast what a person will do, like click-through prediction or churn prediction. Generative models can stimulate how a person might behave, used in synthetic data creation or game AI. Explanatory models try to find why behavior happens, often used in social science research. Effective models especially try to understand emotional state from signals like facial expression, voice, tone, and biometric data. Sequential models captures behavior over time, recognizing pattern across a user session or even their lifetime. Most layer systems blend multiple types together. The data behind behavior models. The data is the fuel. Behavior AI system consumes clicks, scrolls, typing speed, purchase history, location trials, app usage patterns, social media post, voice recording, and even eye tracking data. The more diverse and longitudinal the data, meaning collected over a long period, the better the model. A single data point tells you almost nothing. It's a sequence and a context that matter. This is why tech companies collect data so obsessively. One important concept here is behavioral fingerprinting. The idea that your digital behavior patterns are as unique as your physical fingerprint. Even data sets can often be re-identified just from behavioral traces, which is a major privacy concern. Machine learning techniques used. The ML toolkit for behavior modeling is wide. Recurrent neural networks (RNNs) and LSTMs are used to model time series behavioral data. They are good at remembering contents across sequence transformers, the same architecture behind GPT, and now taken over for a sequence modeling because of their ability to handle long range dependency. Reinforcement learning is used to model agents that learn by interacting with environment, great for stimulating rational human decision making. Clustering algorithms like k-means group users into behavior persons without needing label data. Bayesian models are used when you need to express uncertainty about behavior prediction, which is often more honest and useful. Natural language processing and behavior. A massive source of behavioral data is text, social media posts, reviews, email, chat logs. NLP lets AI extract behavioral signals from language. Sentiment analysis detects emotional tone. Topic modeling reveals what people care about. Intent detection figures out what someone is trying to accomplish. Large language models, LLMs, like GPT-4 go further, they can generate entire conversation, stimulate how a person with a certain beliefs might argue, or predict how someone will respond to a message. This makes NLP one of the most powerful and most dangerous tools in behavioral modeling space. Computer vision and nonverbal behavior. A huge portion of human communication is nonverbal. Facial expression, body posture, eye contact, gestures. Computer vision AI can now read these signals with impressive accuracy. System trained on a facial action coding system can detect micro expression that last fraction of second. Emotion people don't even express. Retail stores use overhead cameras to track where people walk, what they look at, and how long they pause at a display. Airports use gait recognition to identify individuals from how they walk. In healthcare, researchers use eye tracking to detect early signs of cognitive decline. This branch of behavior modeling is advancing rapidly and raises serious surveillance concerns. Recommender systems as behavior models. Every time YouTube suggests a video or Spotify creates a playlist, a behavior model is running. Recommender systems are one of the most commercial deployed forms of AI behavior modeling. Collaborative filtering predicts your performance based on the behavior of similar users. Content-based filtering recommends based on the properties of the items you have already liked. Hybrid systems combine both. The problem is that these systems can create filters bubbles, reinforcing existing preference and limiting exposure to new ideas. More worryingly, they optimize for engagement, which doesn't allow align with users' well-being. There growing evidence that recommendation algorithms amplify emotional provocative content because it keeps users on a platform longer. Behavioral economics and AI. Behavioral economics tells us humans are not fully rational. We have cognitive biases, make inconsistent choices, and are heavily influenced by framing and context. AI models that incorporate these insights are far more accurate than those assuming rational actors. Classic biases like loss aversion, losers feel worse than equal in gain. Anchoring, first number you see shapes and are future estimates. And social proof, doing what others do. Now build into AI system. E-commerce platform deliberately exploit anchoring by showing a crossed output high price next to the share price. AI is very good at identifying which biases a specific user is susceptible to, and that both powerful and deeply concerning from an ethics standpoint. Emotion AI Effective Computing. Effective computing is a subfield specially focused on detecting, interpreting, and stimulating human emotion used AI. This goes beyond text sentiment. It includes physiological signals like heart rate variability, galvanic skin response, sweat, and brain wave patterns (EEG). Companies like Effectiva have built emotion detection system used in automotive safely, detecting distracted drivers, and in market research, measuring genuine emotional response to ads. Mental health startups are using voice analysis to detect the depression and anxiety from speech patterns alone. The opportunities and more is imagine an AI therapist that can actually sense when you are distressed. The risk is surveillance and employee monitoring your emotional state throughout the workday. Social network analysis with AI. Human behavior is deeply social. What we do is shaped by you who we are connected to. Social network analysis (SNA) maps the relations between individual and looks at how information behavior and influence flow through those networks. AI makes it possible to analyze network of billions of nodes in real time. Platforms like Twitter, Facebook use graph neutral networks to predict which content will go viral, who will become an influencer, and how a communities will fragment. This is also a critical for disinformation research, tracking how false information propagates through a social graph and identifying the key spreaders who amplify it. Personalization and user modeling. User modeling is a practice of building a dynamic profile of an individual based on their observed behavior. Every time you use an app, it's updating its model of you. This model captures preference, what you like, knowledge, what you know, goals, what you are trying to do, and a contest, your current situation. In e-learning platforms like Duolingo or Khan Academy, users' models are used to personalize the difficulty, pacing, and the content of lesson in real time. In healthcare apps, behavior models adjust the recommendation based on how consistently a user has followed the advice in the past. The fundamental challenge is the cold start problem. How do you model a brand new user with no history? Biases and fairness in behavioral AI. AI behavior model inherit the biases present in their training data, and human behavior data is deeply biased. Historical data reflects historical inequalities. A hiring AI trained on past decision will encode past discrimination. A recidivism prediction model trained on biased arrest records will systematically disadvantage certain groups. The Compass algorithm used in US courts predict re-offending was found to be significantly more likely to encourage black flag defendants as high risk. Addressing fairness in behavioral AI is technically complex because fairness is itself has multiple definitions that can mathematically contradict each other. This is one of the biggest active research and policy areas in AI today. Behavior modeling in healthcare. Healthcare is one of the high stakes applications. Behavior models are used to predict medication adherence. Will a patient take their medicine? Appointment no shows, suicide risk, addiction relapse, and disease progression. Wearables like Apple Watch generates a continuous behavioral streams, activity, sleep, heart rate that can detect health deterioration before the patient notices symptoms. Mental health apps use passive phone data, how often you use your phone, what time you send messages, and how fast you type to infer mood states. A field called digital phenotyping. This modeling can be life-saving, but the data involved is extremely sensitive, and the model errors in this domain have serious consequences. The future, the generative agents and digital twins. One of the most exciting and unsettling frontiers is generative AI. AI systems that can consequently stimulate specific individuals or population group. Stanford researchers demonstrated this with agents that has persistent memories, formed relation and exhibited emergent social behavior over multiple days. Digital twins take this further, creating a precise AI model of a specific person that can be used to predict their decision, stimulate how they would respond to new product, or even serve as a proxy in negotiation. In urban planning, city scale, digital twins stimulate how an entire population will behave. If a new translate line is added or a policy changes, the line between stimulating behavior and replacing a person is getting uncomfortably thin. Ethical frameworks and the road ahead. The field needs strong ethical foundation. Key principles include transparency. People should know when they are being modeled. Accountability. Someone must be responsible for model errors. Fairness. Models should not systematically disadvantage groups. Autonomy. People's right to make their own choices without manipulation. Organizations like Partnership on AI and the AI Now Institute and the government bodies worldwide are working on regular frameworks. As AI behavior models get more powerful, the gap between the technical capability and ethical governance grow wider. The most important insight for anyone entering this field: technical skill alone is not enough. Understanding the social, physiological, and political dimension of the system you build is non negotiable. Thank you.